Hey y'all, welcome back. So let's get into some more energy transformations today. I know in the summertime, a lot of you love to go to amusement parks, you like to do the rides, and maybe some of you are roller coasters. I feel like you either love roller coasters or you'd rather wait at the bottom with the nice cotton candy. But if we were to take a look at a roller coaster and how it is a great example of energy transformation. These are also a part of your PowerPoint slides. You have these still linked to Google Classroom. Okay, so let's say that we were looking at the track of the roller coaster, and if we were to pick 5 points for the car on the roller coaster to pause, and we were to analyze its energy. This is something that people who design roller coasters really have to consider because you want the roller coaster car to be able to complete the work, do the job of getting the rider from the beginning to the end of the track. You can't have that car stopping short of the finish line. So at point one, right where I see this first arrow of energy here, that car, it does not have the ability to complete the track. It doesn't have enough stored energy yet. So in order to give that car stored energy, I have to first do some work to that car. I have to put it up at a height. Now think about this. If you've ever been on a roller coaster, the very first thing that happens to you is that click, 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 click process as you are being pulled up the first hill. And then at the very top of that hill, you are briefly at rest before the ride really begins. What you've just done is given your roller coaster car gravitational potential energy. It has enough height, enough stored potential in order to transform that into enough kinetic energy for the rest of the coaster ride. People who design coasters, they have to specifically design that first hill to be taller than any other event or design in the remainder of the track. Well, why is that? If you don't have enough stored energy or more stored energy at the start of the ride, you will never be able to transform that energy into motion to finish. Remember, it's the law of conservation of energy. Energy is not created or destroyed, energy transfers forms, but the total amount of energy stays the same. So this very first hill, I have to make sure I get more stored energy here. That way I have enough to transform for the rest of the ride. Okay, so this is the link that's on your practice assignment, and let's take a look at this together. It's the same idea as looking at 5 different stops or 6 different stops if you could pause a roller coaster on its journey up the track. But before we begin, if you notice the roller coaster design, that very first hill is higher than any other feature on the coaster or on the track. So that way I get enough stored potential energy to transform into enough kinetic energy. So above this track, I also have something very important. I have a pie chart of how much potential and kinetic energy is available. So I'm going to go ahead and use the step button. And if I push step, this is going to bring my coaster up to the very first point on the track. Now checking out my pie chart, I have all red, so that's 100% potential energy. I had to store enough energy in the coaster car itself so that it has the ability to transform into kinetic. Now, from points 1 to 2, take a look at that energy pie graph here. Now I have transformed nearly all of my stored potential energy into kinetic. I set the car in motion, gravity's helping it pull it downhill. But to go from points 2 to 3, now I'm starting to work my way uphill. To go uphill is to do work, so I'm going to predict that I need to spend a little bit of my kinetic energy. See how on the pie chart my potential energy increased. That means I used up some motion, and now I'm traveling uphill again to get to point 4. So from points 3 to 4, that's a lot of work to be done. I'm having to use up my motion. I'm fighting gravity to do a little upside down number. Now, don't forget that at point 4, if you predicted that this would be 100% potential energy, you wouldn't want to be stopped upside down at the top of that hill. That wouldn't be a good situation for physics. So you still need enough motion to push you through point 4 and to go down the opposite side of the loop and into point 5, which is once again giving you full kinetic energy. And from point 5 to 6, you need to use up a little bit of that motion, storing some energy again at the top of the hill at point 6 to finish out your coaster track. So for your assignment, you have an option of analyzing that roller coaster track. It's called roller coaster energy. And you are using that same animation to explain what's happening to the energy transformations at those points along the track. If you feel very comfortable with roller coaster energy, and if you feel like you need something a little more challenging or a little more creative, you have the option. So again, you do not have to do the roller coaster energy. You can choose to do energy of a skate park. There is a new assignment if you choose to do this, and it will take you to this simulation here. So if I have a skater and I put him up at one end of the skating ramp, I can choose to look at his energy through a bar graph or through a pie chart of energy here. And I can look at how his energy transforms between potential and kinetic against the total amount of energy that he has. I can try this on different tracks. So if I put him here and let him skate, I can watch the different transformations of potential and kinetic energy as well. I can do something more creative in this way if I select the playground option. Now, this is where you really get to test your understanding. You can build him a skate track, and you are connecting in different lines of track. You can kind of push it, pull it, twist it, turn it in any way that you want here. And you can test out how successful your course design is. If he's actually able to have enough stored energy at the beginning of the track to make it all the way to the end. Now, on this design that I just did, if I put my skater on the beginning of the track, is he going to be able to have enough energy to make it to the end? And that's a no, because I need to remember my law of conservation of energy. I need enough or more stored energy at the beginning of my track. That way he can transform what is stored into enough kinetic. So you may try, and you may want to adjust some of your energy here, some of your track design, so that way your skater has enough stored energy to make it all the way down your track. And you have an assignment link for this as well. This is also attached to Google Classroom. And again, it is your choice. You can either do the roller coaster energy if you feel like that's more where your speed is at the moment. Or if you want to get a little more creative, if you feel like you really understand the energy transformations, you can try the Energy Skate Park Simulator. All right, guys, I hope you have some fun with this. I'll see you soon. Bye-bye.